long, long time ago, I can still remember how that music used to make me smile. And if I knew if I had my chance that I could make those people dance, and maybe they'd be happy for a while. But February made me shiver with every paper I deliver. Bad news on the doorstep. I couldn't take one more step. I can't remember if I cried when I read about his widowed bride. But something touched me deep inside the day the music died. So bye, bye, Miss American Pie. Drove my Chevy to the levee, but the levee was dry. Them good old boys were drinking whiskey and rye, singing, "This will be the day that I die."
All right, Pat. Thank you, man.
Good, man.
We had to get to the chorus on that one, man. That's a classic. It's a classic track.
Yeah, everyone get in.
Welcome, man. Welcome to the
Manny,
construction. Thank you so much. I know that I've actually been looking. I was telling Angelina that when we were coming here, I was looking forward to this show because it's going to be a very interesting conversation. I think.
I hope so.
It's going to be very, very good. So, Pat Moore.
Yep.
You're a site superintendent.
Yes.
But you're also side gig hustle. You're an instructor.
That's right.
Now, a specific kind of instructor.
Yep.
The official title is what? What is
teacher? I don't know.
You're just an instructor. So
well, what I instruct is very unique, but I'm just an instructor.
Well, I think it's more than just an instructor, right? Because this is, first of all, I don't know much about this side of the industry. I'm fascinated by it that whoever has the ability to gain these skills, lots of respect for them. And I know that I met you through Frederick, who was on the show last year.
Fred.
Huge shout out to him because he's
you.
the one that spoke highly about you. And also he's a student of yours as well.
He is now. That's right.
Which is amazing.
It's awesome.
And he's a young kid who's craving, always wanting to learn more.
Yeah.
But I know that off mic before we got started, you were giving me the background history on the word stereotomy, right? Where it all comes from. You want to share that with everybody right now?
Sure, yeah. The etymology of the word. So stereotomy is Greek. So break it down. There's two kind of parts, stereo and then to me. Stereo is 3D space, volume. So if we think of stereo as like music, it's where you could record from two different locations in the same room to get the stereo of that sound. And then the to me is to cut. So it's cutting three-dimensional solids like stone or wood into particular shapes or forms.
So right now, these days, it's anything that you can cut or shape in any material. Because you've seen people, I guess, cut, shape, work with foams, plastics. Yep. But it all started with wood and stone, right?
Well, and maybe some sheet goods like steel or, lead or something like that. But yeah, I think like way back in the day, it would have been stone and wood, like timber. And then joiners as well, doing interior finishing. So if they have like some wood paneling and then let's say like a dome or something, or like a curved doorway.
Old school plasters and things like that.
Yeah, they would be using that sort of knowledge.
All right, this is going to be a good chat. I'm digging it. So a quick shout out to the boys out west, Builders and Brews. They're doing the great things where they get together and they have a bunch of contractors, tradespeople show up at a bar, whatever, and they just basically have construction conversations. That's all it is. So the boys, thanks so much for the tea that you guys sent out. I want to give out your deets as well. So www.historicalcarpentry.com, which is the website, but you really don't focus on that. You focus more on social media, on Facebook and IG, School of Stereotomy, and then IG is also the
Stereotomist.
Yeah. That's it. So everyone's going to get a lesson here on that word particularly, but where do we want to begin this conversation, Pat?
Well, I don't know. I mean,
why did you get into it? Why did you particularly, you're a site super, but.
Yeah, I mean, it's not something that I chose to get into. I didn't know this existed until I moved to France and was living in France and doing this very intense, what Fred did similarly. He was there for a brief amount of time, but I was there for several years and I did this whole very traditional apprenticeship program that they have that has been in existence since the 13th century. So it's been around for a long, long time.
And the techniques are still used to today.
Yeah, totally, 100%. Yeah. But actually, it's been around since medieval times, and that's what when we romanticize about the medieval ages and in construction specifically, like cathedrals and stuff. This is the knowledge, and this is the group of people that made that happen.
Is it a dying art? Because I consider it more of an art than a skill, right? Am I wrong to say that, or are we saying it's two sides of the same coin?
Yeah, exactly. Two sides of the same coin. So it's a skill, and it can be used and can become artful. So of course, I think like a lot of skills in the beginning, it's kind of utilitarian and practical. But if you keep going down that road, you eventually get to a point where it's artistic, because you're pretty good at it. And it's beyond the practical purposes. So you start building little models and, little pieces that look like art pieces.
I mean, still to this day, I thoroughly enjoyed the conversation I had with Fred. I personally can't wrap my head around. I know that he tried to explain, and you're going to do the same thing here.
Yeah.
How to visualize something in a 3D component and how to cut it in that visualization. That's challenging, and and a lot of respect to all the kids that are or even older, probably older tradespeople that are getting into it, that are actually embracing it, learning it, and understanding it. But I guess if I gave myself the time to actually understand it, then I eventually would see what you guys see.
For sure, like anything, practice.
That's all it is.
Get good at it. But in France, they start this thing off when they're really young, 14 years old, and they have a decade worth of education that they have to go through, and they have to prove themselves at certain points, and they use this knowledge to do that. And here in America, this is something that we never really we had it, and it's still around a little bit, but it's something that, for a lot of reasons, the Industrial Revolution and framing and productivity. Doesn't really value it. Yeah.
Outside of France, who else is doing it?
There's ultimately three main cultures and countries that still practice it and maintain it and use it, let's say daily, and that's the French, the Germans, and the Japanese. But that's not to say that other countries don't use it. Like the Swiss use it, the Koreans use it, but mainly it's the French, Germans, and the Japanese. And in fact, they have words specific for stereotomy as it's used by carpenters. So in France, it's this word called l'art du trait. Okay. It's the art of trait. Those things get lost in translation. And then the Germans, they have a word called shiften. And then the Japanese, it's kikujutsu.
Kikujutsu.
Yeah, kikujutsu. And this is the knowledge that they practice when they're young that enables them to maintain and restore their cultural, architectural identity. So for example, if you want to, like in the Japanese context, if they're restoring this ancient pagoda with these big, massive overhangs, that we quite often recognize as Japanese architecture, it's the knowledge of kikujutsu that enables them to lay out and cut these swooping eave lines, where they have these curved purlins and fascias and other, hip members, and also the complex or seemingly complex bracketing system that supports this large overhang. Yeah. All of that stuff is used using this drawing technique of stereotomy or kikujutsu.
It's almost as if you look at it for the first time, and it's a glance, you look at it, you think that tree was made that way.
Yeah, in some ways they would use the wood fibers of the curved part.
But it's not. It's all that skill and that art. That's how it's the connecting point where it's like I'm still trying to figure out how to get to that point.
Yeah.
But sure. I guess my real question is, why can't Canada be one of those three and be a fourth? Why can't we start? Do we have the population here? Are there the tradespeople in this industry that want to continue it here?
Yeah. Oh, totally. Yeah, for sure. But in America, just people in general. Yeah, for sure. We're all humans. There's nothing special about the Japanese, Germans, or the French. It's just they have this knowledge that we didn't really value or, have the need for it. But I think as time goes on, people are recognizing the value of it. So I totally think that there's carpenters out here in Canada specifically that would they would take the time and spend their money and to learn something, because it's this is especially this isn't, it's not a weekend course or like a product you buy at you just buy this thing and you apply it. It's not like that technology that we often associate with problem solving, like, oh, you got a problem, apply this technology and you're this IST and it solves it for you.
Yeah.
It's a skill that takes a long time to get good at, but it's a very, very valuable skill that, if you get good at it or let's say master it or something like that, you are like a walking human AutoCAD or SketchUp.
Yeah, basically.
Yeah, and then with very basic primitive tools, you could lay out and solve any complexity, like any intersection or any object or any design that you have in your mind. It's the ultimate. How can I say this? The ultimate thing that's holding you back when you get good at this is, it's kind of weird to say, would be your own imagination. It's not the technology. It's not like, okay. So for example, I often give this is in carpentry. When you go to school and you start learning about carpentry and roof framing, or stair building, they'll apply this tool, the framing square.
Yeah.
And it's very common. It's all good. It's wonderful. It's an amazing tool, actually. It's quite versatile. But you can become dependent upon it. That, okay, if I have a hip or a valley or staircases or whatever, I have to apply this tool to it. And that's the limiting factor, is, okay, if I want something outside of that, well, if I can't use my framing square, then it's no good.
Yeah.
Whereas with this is far beyond any tool or technology. It's your own mind by drawing it out.
So you guys have two battles here, right? Because you've got the evolution of just construction in general, how we basically have created such a mass production of construction that this is your trade, this is your scope. So when you're a framer or whatever, you're dealing with wood, that this is what your capability is.
Mm-hmm. Specialty.
Yeah. But then you've got the skill set and the art that takes a lot longer to learn, but then the market's not really willing to pay for that skill and art, right?
Well, I would say yes, they would. I mean, I think like any good skilled person, you're valuable.
Of course.
And so if you have that skill, people are willing to pay for it. And it's not one of those things where it's like, I can just take that technology and apply it to this problem. It's not like that. It's okay. It's across the spectrum of skills where, okay, I can apply that knowledge when I'm doing roof framing, or I can apply that knowledge when I want to design something, or I'm building a deck, or it's not just one fixed thing. So it's valuable across the board in your skill set, if that makes sense.
No, it totally makes sense to me. And now that I've got you here in the studio, I wanted to ask you, because I've had something in my head and I have no idea how to build it, but it was always kind of, it came from the idea of taking an umbrella. Mm-hmm. You know, the way that you see the brackets underneath an umbrella canopy, right?
Yeah.
Taking 1/4 of that and making that some sort of a structural canopy member.
Sure. Mm-hmm.
You guys would know how to do that. I would have no idea how to do that.
Yeah, sure. Yeah.
But how would one start to take that element and try to figure out, how do I do that? How do I take timber and create 1/4 of an umbrella canopy in that same roundness on top, but angular underneath?
Right. Well, I mean, if I was to walk you through it like a step by step, I mean, you would have to first kind of get your design nailed down, either by hand sketching it or something like that. And then when you got the design down to like 90% or 95%, okay, this is what I want. Then you go to the drawing board, literally, where we will take a table this size, or larger, the concrete floor often in the shop, and start laying this out full size or full scale on the floor, and start drawing it out piece by piece. And so you first
just flat.
Yeah, just
draw
flat.
it.
It's a two-dimensional perspective. Yeah, so you have like a plan view, elevation views, side views, all these different views. And it's by doing, and that's what the stereotomy is I'm taking this object, so in this case this umbrella, and I'm slicing it in multiple ways, or I'm viewing it from all these different angles. So top view, like a bird's eye view, side view. I'm looking at it, let's say, from perpendicular from the angle of the umbrella itself, so I can see this like I would have to sheathe it or something. And by doing all of these different views, I can get information from each one of them to then be able to lay out my timber. That will enable that, they'll, let's say, give me a curve or give me some, a real length, a real angle.
So then from there you start becoming three-dimensional. You start.
Yeah. Well, the drawing itself, it's 2D, but it represents a three-dimensional object. So, for example, like your plan view, you'll have, left and right, back and forth measurements.
Yeah.
And then on your elevation view, you'll have a height measurement. So it's a combination of using those two pieces, those two views, that can give you, let's say, an angular piece that's coming up on an angle, like a rafter.
Yes.
Something like that. Yeah.
And then there's also techniques on how you can choose how those rafters or those pieces of timber are going to intersect with each other.
Exactly.
Right?
Yeah. So when you're doing that process, you start drawing, you just draw as much as you know. What's the size of this thing? What's the plan view of this thing? What's the elevation view?
Drawn at full scale.
Full scale, yeah. And you can, and we also draw it scaled down. We can make little models, but the scaled down drawings, the only thing that changes when you scale something down is the length. The angles still stay the same. So let's say historically, or even today, you can just grab the length off of your scaled down drawing and then just times it by whatever the scale is.
Yeah.
So historically, they would take a pair of dividers and just grab that length and then step it off, whatever the scale was. And that gives you your real length, but then the angle doesn't change. So you just still grab your angle off of your drawing.
Yeah.
And you don't know it mathematically, or using trig, you don't know what the numerical value of that angle is or that length, but you see it as a visual representation. Like there's the line length, that the length of that line is the actual length of the piece.
Now I'm beginning to see it.
Yeah. So that's why drawing it out is so vital, because it's visual, you see it, it's right there. And that's what's so powerful for tradespeople, because tradespeople, for the most part, are hands-on visual learners. Yeah. Yeah. And this is no better way to learn something than to draw it out full size. And you can say, well, see, like this is what it looks like. There's your actual length. There is your actual angle. It's not witchcraft, whereas we often get taught using math, trig. And I'm speaking more for myself, but I know a lot of people too, math isn't their strong point. And that's often why we get into the trades. We're not, let's say, academically smart in that sense, but we're smart in other ways. But we don't have that part of our brain isn't the strongest part, using the math. So it's kind of, in one way, it's like, well, why would you take these people who aren't strong in that skill and hammer this skill into them? Whereas there's other methods, like this drawing technique, that are far more empowering. And it's far more empowering to tradespeople than the math is, because especially when you start getting into curves, like, single curves or double curves, compound curves, stuff like that, you could still draw it out and solve it and lay out and cut your pieces. Whereas mathematically, if I was to sit there with a calculator, well, I wouldn't be able to do it, but you'd have to be like a genius, I think, to solve
the numbers that are
associated. The numbers associated, yeah.
But an actual drawing, actually, it's right there, in front
exactly.
of you.
Mm-hmm.
So I guess the unfortunate thing is, I want to ask you, why did you get into instructing it, but the majority of trade schools don't even teach this?
Well, they don't even know it exists, probably. Yeah. So after having my experience in France, learning all about this and, doing this masterpiece and all this stuff, it's just so France and Germany, it's just part of their apprenticeship. They just learn this stuff since the get-go. So there's nothing really special about it for them. And I got a couple of stories about that, but when I learned about that and then coming back to Canada and, to the US for that matter, I was just kind of blown away that there's this whole like sea of knowledge that exists that we have no clue is out there.
Like it's such a tool that's not being used.
It's huge. It's massive. It's actually, I mean, it's so important. Like I say, I repeat this like to nauseum, but it's so important that UNESCO lists it. UNESCO, UNESCO is an abbreviation for the United Nations Education, Scientific, Cultural Organization, has listed this knowledge onto this list of intangible cultural heritage of humanity. Because this is the knowledge that has enabled human civilizations to build the cathedrals and the churches and the fortresses, military applications for it. And in fact, in 1799, it was a military secret in France up until 1799.
Wow, I didn't know that.
Yeah, Gaspard Monge, who was this mathematician in France, the supposed father of descriptive geometry, would teach this stuff in the military to like military architects and engineers. For the way to solve or design star forts and bridges and walls and stuff like that. So the stonework involved
to be indestructible, to last longer.
Or just is more like so star forts. It's the way that the fort is designed. You know, like you have these angular points at the forts, and it's the way to defend those walls with other angular walls with cannon fire. So the way that star forts, I mean, from what I understand, the way that star forts work is, let's say way back in the day, when there was a fort, let's say a castle with a straight wall, soldiers would just rush the wall and try to get as close to the wall as possible because the cannon fire or archers can't really get to them because they're too close, and they would put up their ladders, and then that's how they would get the siege,
take over
the fort. Whereas when star forts started to be developed, it was kind of like the modern day arms race. Is how can we make these walls pointy, and then have other supporting walls behind that are also pointy, but that offers cannon fire or support along this length of the wall. So when soldiers can rush the wall, they would still be able to fire at them. Yeah. And so it's all the way the angles work out, and the sloping of the hills and stuff like that. And so with Gaspard Monge, he would design these forts to incorporate that design feature, and then they would use this stereotomy, or what some people call descriptive geometry, to solve for how do we actually build it with the stone or timbers or whatever.
In today's climate, outside of those three areas there, who's using it? Like, who's building today with some of these techniques going on?
Well, essentially we all do. Everyone does it without them knowing that this is what they're doing.
Okay.
Yeah. So let's say, like timber in the timber framing industry, we have mortise and tenon joinery and stuff like that. So there's elements of laying out your timber, this three-dimensional piece of wood, and how can I cut this piece so another piece can join it and it's connected. So it may not be in the kind of traditional sense of I'm making a drawing and I'm going to lay timbers on it and then transfer that information onto my timber, but you still have the notions of it. I have this three-dimensional piece, I have this three-dimensional piece, how can I put these two together? How do they interact? So that's the kind of the basics of it, but
people in the industry do this all the time.
They do it all the time, yeah. Mm-hmm. Yeah. Like, so for example, like stair builders. Stair builders use it without them knowing that it's stereotomy. They'll, let's say when you want to build a quarter-turn staircase in a residential house. A lot of people will draw the stringer on the wall of the house. And then that gives them all the layout for the treads, the risers, and all that stuff. That's essentially stereotomy. You're drawing out this two-dimensional representation of the stringer or the treads or this three-dimensional piece or the staircase. So they do it.
But then all of a sudden you start adding the element of either a curved one side railing or whatever. It's a hockey stick or whatever. Right. You got pies or whatever. It's just like you start adding all these different elements.
Exactly. Yeah. So then you can do, like, let's say, a plan view, and then you can get your pie-shaped winders, off your plan view. Now,
here in Canada, though, you get a lot of stair builders that are actually making this in the workshop, assembling it, gluing it, clamping it, put it all together, and then delivering that full stair as a unit, and then installing it on the job site. I know that in America, a lot of Americans, tradespeople, stair people, they actually build it on site and then do all that work, clamping and turning and gluing and all this other stuff. So there's that little bit of a disconnect between how Canadians do stairs and versus Americans do stairs.
I don't know.
Slightly different. I mean, because I've always shown these units arrive on site, and the Americans are always asking me, well, why not build it on site there? Right. Or take out or build on top of your construction stairs, a new stair, right? Why do you spend so much time and effort? I always done this. I've always spent my time and effort to build proper construction stairs. I just don't need stairs being built out of 2x6s or 2x8s and just like slap them all together with cleats on top. I'm like, I'd like to actually have a stair, but then you get rid of that. And a lot of people are like, why are you getting rid of that? It's such a nice stair. I go, well, it served its purpose at that time.
Yeah, it's construction stairs.
So there's two ways of, I guess, looking at it that way, right?
Well, I mean, there's a lot of companies in the U.S. that will...
They'll do units as well, too. Yeah, for sure.
Yeah.
But I see that a lot of people they prefer it on site.
I think that's a kind of an old school mentality.
Yeah, no, for sure. That's where you bring that tradition back, right?
Well, I mean, building things on site is in some context is a lot slower. You know, if you have a shop that's heated and you got all the tools around you, it's far more, controlled environment, and the quality is a lot better. It's just you have far more control over it than building something out of the back of your truck.
So how is this shift from you being a student to you being the teacher? Well, how did that become a thing for you?
Well, like when I came back from France, I had this experience and I've gained this knowledge that I wanted to show people that you got to like check this stuff out, man, because it's quite profound. And nobody was interested. Nobody was. Everyone's like, yeah, that's no. Like,
welcome to construction.
Yeah, exactly. Yeah. I mean, I contacted hundreds. Like, I literally at one point I sent out over 300 emails to schools across.
And it was just crickets.
Nobody. And actually, I'd follow up. I'd follow up with phone calls. To try to talk to the dean or talk to whoever the program coordinator or whatever, or the teacher themselves. And they're just like, no, I've never heard of this. I've been doing this for 30 years and I never heard of it. How can it possibly exist?
That statement's never said in construction.
Yeah, exactly. Yeah. So, I mean, it's probably just me butting my head against the wall and not going anywhere and saying, okay, look, like there's something to this. If the UN is saying that this is important and you have these other cultures that this is what they do. So like a bit of a tangent here, but when I was living in France and learning the basics of this sort of drawing technique, there was this 14-year-old kid. I was living with one of these 14-year-old kids, and he said, "Hey man, you want to," like in French, of course, "Hey, you want to learn some timber framing?" And I was a decade older than him. I was 24, and I was like, "What the fuck? I mean, I'll learn timber framing, like I'll teach you timber framing." Like this is my ego speaking, right?
Yeah.
And he said, and I said, "Sure, okay." And in 5 minutes, he did this little drawing with a bunch of these little triangles. And he goes, yeah, so you see here, like that's your hip elevation view. And on that view, you can see the real length. And you have your plumb angle, you got your level angle, you got your cheek cut. And I was like, wow, in 5 minutes, this guy did this thing and he's 14. Okay, well, maybe I got something to learn, Okay, I'll shut up and I'll listen, So to come back to having these experiences and coming back to Canada, and then now butting my head against these people who don't want anything to do with it, have never heard of it. They often say when you hear that word stereotomy, they think stereo or like some kind of music system or something. I thought, okay, like I got to do something with this. I because I know it's profound. Yeah. I know for a fact it's profound. And how do I know? It's based on all the historical stuff that occurs in Europe and in Japan and in the Asiatic countries. Like that's how they did all that stuff. So there's something there. And I just continued. Emailing, and then eventually I'm like, okay, well, screw it. I'm just going to start teaching courses. I'm going to open up my own little school, my tiny little school, and I'm going to start just putting out the word out there on social media that I can offer this course. And yeah, little by little, it was tiny. You get one person came in and go, this is cool. Okay, I'm not sure how I can use it, but okay. And then as the years go on, it starts growing and growing and growing, and it slowly grows. And I think it's to the point, maybe not as big as I'd like it to be, but it's certainly to the point where it's more known in the industry and more people are knowing about it. And it's, people like you, thanks Manny for coming on and talking about it.
Yeah, I'd love it. Whatever I can do. How many students have you had during this since you started? Well,
I started in 2014.
Okay.
I started this kind of journey, and I've had hundreds of students. I mean, I've now developed these online courses where people can come and learn, at home or whatever. And there's a couple of hundred online students. And then when I do I now have a circuit where I go and I teach across the U.S. into Mexico and Canada and in Europe. And so it's every month I'm gone teaching.
Wow.
And so that's, every time you teach, you're teaching to 30 people or whatever. And now it's hundreds or a couple of hundred, a few hundred a year. So of course that then spreads and more people learn about it.
But teaching it though, it's not a one-day course, or how does it?
Well, there's variants. There's all kinds of workshops that I offer, from like a weekend workshop to a week-long workshop to 12-week workshop to the online courses. The online courses being the most comprehensive courses because you have all of this time. You don't have to, come to a physical location for a period of time.
And to get a hold of you, it's all done through social media.
Social media,
so that's how it's done, right?
Yeah, social media, the website, and looking for these schools that I teach at.
And still, have you gone back to the schools to ask the deans and program directors, whatever, and do they understand what it is now, or they still don't?
Some of them do. Some of them are catching it. Some others still are just, nope, not interested. You're still kind of banging your head against the wall with some of those people. And it's probably one of those things, maybe like how the metric system was introduced. You got to wait for the old to die for the young to take over. And
not in our lifetime, man. Not in our lifetime. I want to share a little bit of history here because obviously this is a little bit relevant here. Wood beam structures. Do you have any idea what was the largest wood beam structure?
The largest is, I think, is a Japanese temple.
I've got the largest clear span wooden structure in the world stretched 1,072, talk about imperial metric, feet tall and 296 feet wide, built in 1942 to care for the U.S. Navy blimps. The Tillamook home was one of more than 15 such hangars across the nation in use during World War II.
Oh, wow. Cool.
So that's pretty big at that time, right?
Yeah.
And then the world structure now, I guess Wisconsin has a 25-story high, 284 feet. The Ascent MKE building located in Milwaukee, Wisconsin is officially the tallest mass timber building in the world, moving ahead of Norway's 18-story tower in Mosjø. But then Norway came back and they ended up building an 85.5, back to the metric, meters tall structure. So then it reclaimed it. Now, what is currently the largest wood frame building in Canada?
Largest wood frame building in Canada. I would assume it's probably a building in Vancouver.
BC. It's in British Columbia. The Brock Commons Tower.
Okay. CLT probably or something.
It's at the University of British Columbia campus, the world's tallest wood building at 18 stories.
Yeah, right. I think it held the record for a little bit.
Probably for a little while, yeah. But I mean, I'm always fascinated by the wood structures there. Yeah. So that's just going off a little bit of a tangent. So I'm glad that, it's taken you a little bit of time to get some traction with this, right?
Yeah, it's been over a decade. Well, it's close,
Yeah. Wow.
Yeah. Sure feels longer than a decade, though. Yeah, because you're constantly fighting uphill. It's these uphill battles.
But you still have a day job too, right?
Yeah, I still have a day job.
And then you're still doing this on the side just because of the love and passion for it. I mean, are you not at the day job as a site superintendent and all of a sudden thinking in your back of the head, what else can I do for course?
Always,
right?
Always, man. Always.
Because you're still learning yourself too. You're probably coming across things that you haven't come across everything yet.
No, of course not. I never will.
If they were building these things centuries ago, there's probably so much that you still don't know that was built or used.
For sure. Yeah, totally. Yeah.
So where do you see it from now? Like, how do we get more and more kids interested in this, or just people in the industry at all interested in this and being more advocates like yourself?
That's a good question, Manny. That's like something that I've been hassling, or been struggling with the entire time, is how can I make this more, I think just simply awareness is probably the biggest one, is to know that this stuff exists, that this is a possibility, and look at how far you can take this and what you can do with it.
It should almost be like a prerequisite. If you're in a trade school, that you should do a mandatory course on this.
Oh man, 100%. Yeah, for sure.
Like should be part. You can't graduate unless you do this.
Exactly. Yeah, I think it's just a matter of time that it's going to be part of this certain programs. They're going to integrate it in these programs inevitably because it's so empowering to the kids. I mean, if you get a 14-year-old who can outperform a 30-year-old who's got 15 years of experience, something like this, in two different countries, there's something to it.
Yeah.
Yeah.
But then there's I'm going to just group it all together, the North American eagle.
Sure, of course. Oh yeah, totally.
Right?
Yeah.
I don't think the eagle is much in Europe as it is here.
They still have it for sure, man.
They still have
we're all
it?
humans.
Yeah.
Yeah, we're all humans.
Okay, all right. Is it the same in Japan?
Oh yeah.
Really?
Yeah, it's everywhere, man.
It's got to be in Germany.
Yeah. Oh, say no more.
But it's nice that you have that awakening moment, right? Where you kind of like, okay, sure, you had it, and I'm sure a lot of other tradespeople are going to have it. What am I going to pick up from this kid?
Right. Exactly. Yeah. For sure. Yeah. You have to be open. I think you certainly have to be open-minded and just be willing to know that you don't know. And once you're okay with that, then okay, you know, learning can begin.
But that's the best part of ignorance, man. That's actually how you learn more.
Yeah. Oh, totally. For sure.
So how would you speak to someone who is, I guess, either intimidated or just not really aware of this? How do you start that conversation? What's the first thing you tell them?
Good question.
Because a lot of people will listen to this show, and I'm sure a lot of people listen to Fred's show as well. And like me, they still try to figure out how to say the word, right? But eventually we get past that. But then we try to wrap our head around that whole paper side of things,
right?
And then go from there. But I can see a huge amount of tradespeople actually embracing this. It's just a matter of how do we present it to them so that they can embrace it, right?
Yeah, good question. Yeah, I don't know.
That's a challenge, right?
Yeah, that's the constant challenge. Yeah, I think social media is a big one. The internet is showing that these things are possible. This stuff exists, and here's what you can do with it. You
were totally right earlier on where you were saying that your only limitation is your imagination.
Yeah, exactly.
Because I've had that idea about that umbrella since the first day of construction.
Oh, yeah.
Maybe I even had the idea back in high school in drafting class where I was trying to think. When I was the only one that built a model in drafting class. I was the only one that finished, right?
Okay.
And talk about angular. I actually built a house that was designed for a cul-de-sac. I wanted to design a house that was in the shape of a pie.
Oh, cool.
My instructor was dismissing it, going, why do you want to do that? You're going to have certain rooms that are going to be so small. And then let's fast forward decades now, and they're building condo structures that are building with these wedges, right?
Yeah, exactly.
So, but like I was building a residential house with a pie-shaped roof line, and we had to figure out how to do peak roofs.
Perfect.
I had no idea how to do it, but I was drawing it. But this is it. Exactly.
Yeah.
This is, and the thing is, if my instructor
knew of it,
they would have kind of
guided you.
Exactly.
Yeah, exactly.
You don't know where I could have gone as a result of that.
Instead of that getting cut, saying, okay, well, we can't solve that. It's, you're crazy to think that. Well, here's this other method, or here's this other set of knowledge that, this is a great idea, and let's go check it out.
There was compromises because I actually ended up cutting the back of the house and not into a point anymore.
Oh, okay.
Because he's like, you can't do that. You can't have a point in your backyard. And I was like, why? You'll have two sides now to your backyard.
Oh, nice.
Not just one side.
Okay.
And then he would look at me. He didn't really have anything to say about that. But he goes, yeah, but we can't build that. I was like,
yeah, you can.
Yes, you can.
Of course you can.
What do you mean? You can build anything. If you think about it. What is it? Like, it was recently from the pyramids to the next biggest structure was the Eiffel Tower. That time period from the pyramids, nothing was built bigger than that Eiffel Tower.
I mean, taller?
Taller. So it took that, but anything can be built. If you look at
there's the cathedrals in Germany. They had cathedrals.
Were they taller than the Eiffel Tower at that time?
Well, the Eiffel Tower was built in like the 1800s.
Yeah, so it was just that span between the thousands of years from pyramids to modern day technology building that, right?
I don't know. You'd have to look up how high are the pyramids, and then how high are some of those cathedrals?
I don't know. Maybe
like
it's something.
I mean, they got some really tall cathedrals.
What I mean, my point is that we can, like as humans, we can build.
Yes, exactly.
It's the only thing is that we have an imagination. We haven't just pushed our imagination to build it
right
this way.
And here's this knowledge that enables you to do that. Yeah, and that's it's like any good mentor, any good guide. If they're well versed in a variety of subjects, they can better guide the kids. They can better guide their students,
and the kids will actually feed into that and also educate the instructor.
Exactly, and then it's kind of this perfect
full circle at that point. Now you've got a collective of people brainstorming, trying to figure out.
Yeah. Instead of just the teacher with the old school mentality, the teachers, I know everything and don't question it.
It's all garbage, right?
Well, yeah.
But that's construction.
A lot of it, I mean, there's a lot of old school people that's their way of doing.
I've been doing it for 30 years.
And it works, and don't tell me anything else. Yeah. But whatever. things move on. Things
so if
continue.
you want to get a quiet kid who wants to get into this, but they're very shy and they want to, okay, what's the first tool that they should have in their arsenal?
A pencil.
A
pencil and paper, or just a drafting, not even a drafting board, just
a
like
garage floor, concrete.
Garage floor, sheet of MDF. That's the online courses. That's all you need is a 4x4
pencil
sheet.
does great on MDF.
Yeah, it's great.
It's the best.
Yeah.
HB, right? Carpenter's pencil. It's the best.
Mm-hmm. So pencil and a little straight edge and a drafting triangle. That's all you need. So with all those 3, maybe 4 basic rudimentary tools, you can build anything you can
I
possibly
once saw
imagine.
a landscaper with a oversized framing square, like a triangle. Sorry, and it was like a 3
like
foot
a folding one,
right? And it was amazing. I actually saw it, and I was in Ireland, and I ended up buying one. And bringing it back, and that was quite the fiasco because even when it's folded, it's not carry on. It's not,
still like 6 feet long.
Yeah, exactly right, and raises all kinds of bells and whistles during security.
Perfect.
But I mean, like I brought that, and I pull that out all the time because I want to. It's actually like you said, it's easier to visualize something when it's on a bigger scale.
Oh, for sure. Mm-hmm.
So you can actually start to see where things start to go from there, right?
Yeah,
so
exactly.
I'll put that thing down and start to create from that point.
Right. Yeah, that's the best thing, in my opinion. That's one of the best ways of doing it.
So just start with a pencil and basically just start with your imagination.
Start drawing things out. I mean, if I was to walk someone step by step again, you would draw things, you would draw as much information as you know of your design. So, whether it be it's this side, this shape on plan view, or this height on elevation view, draw that out. And by drawing these things out in all these different views, you gain more information that enables you to continue down the road. And then eventually you get all of your information to then lay out your stone or timber or whatever. And then you can lay that out, cut it, and assemble it.
So I want to talk a little bit about joinery.
Sure.
And where's all the original, like the origin of that? Like where did, like, I mean, Japanese and everything like that. You start seeing, I've read things where you've seen people dismantle Japanese structures piece by piece and then reassemble it again. And they fit right back to the way they were first done.
Mm-hmm. Okay.
So it's like they're not using modern day technology of fasteners and glues and all kinds of stuff.
Well, they still do.
They do? Really?
Yeah, I mean, this is a kind of a romantic view that we have of joinery, and especially Japanese joinery. Yes, they do have very elaborate joinery. Like, I'm not taking that away. They're complex.
Yes.
But they still use glues and screws and like modern day things, In fact, I went to Japan for a couple of weeks with 2 of my students. We did this exhibition for a museum in Japan.
What city? What's it?
Well, the museum is in Kobe. Where you get that famous beef, Kobe beef. There. But we flew and stayed in Osaka and then checked out Kyoto and all these other places. But interestingly, as we're visiting these temples and all these things, yes, they use joinery. But for example, there was a moment where we're walking into this kind of grand entranceway with a big gate, and it's all this wooden timber. It's massive, these massive structures. It's very impressive. And often the posts of these structures rot out because that's the element that's right on the ground or sits close to the ground. So over the centuries or millennia, they rot and they got to replace them. So they replace them with these very elaborate scarf joints. And this is what we often see as Japanese joinery being so complex. There are complex joints, but I remember one time looking at this joint and I was like, oh man, this is fascinating. Let's do it. So we're like, I get down on my knees and there's just 3 of us looking at this thing and we're like, holy crap, that's really cool. And then sure enough, like I'm looking close and there's a Robertson screw. There's a Robertson screw toe-nailed into this thing that's all rusty. And I'm like, there's no way, man. Because it's just it's like I can't compute. I didn't
see that.
Yeah, it's not what I want to think Japanese joinery or something like this. It's not fitting this narrative or not fitting this fantasy of mine. So sure, so I'm looking around and I continue looking around the post and there's on all 4 corners these toenail screws going into it. Yeah, into this 13th century structure. They don't have this same like taboo that we have when it comes to wooden joinery. Okay. We often like to think that the Puritan mentality or the Puritist mentality is, I built this thing by myself with my own hands with no just joinery or something like this. Yes, that people very eccentric people have done that, but realistically, that's not something that if you want to make a living doing is gonna I say that, but there's always going to be one person who's going to give me flack for it. As always.
Course.
But generally speaking, most people use modern day technology. And this is, you don't think the Romans used metal in construction? Of course they did.
Of course.
Yeah, they have, we used metal in construction.
They used whatever was out there. That's all.
It's crazy to think, I'm not going to use this because I don't know.
I'm a purist.
Exactly. Yeah. It's
no, the structure needs to stay.
Right. Exactly. The structure needs to stay up. I mean, the Romans used metal even in timber structures. And this is when, coming to timber framing, there's this whole like mentality of if you put any metal into this thing, it's this whole other category of no longer timber framing, but now post and beam. And this is uniquely an American perspective.
Yeah.
Yeah. Whereas the rest of the world, it's just carpentry. All of that is carpentry. If you use metal or you use just joinery, it's all under carpentry. And as a carpenter, you got to know about it and should be using it.
So why is there segregation here? Like that's just a North American way?
I mean, I can speculate and I can give you my educated guess on that. But I think it's, I'm coming from the timber framing industry or world is, after World War II, the timber framing world kind of died out because of the Industrial Revolution, not the Industrial Revolution, but the ability to mass produce conventional lumber and then soldiers coming back, they had all these GI homes that were being constructed. So you get suburbia was being constructed, right? Like so all of this kind of this sort of like assembly line technology was being like massively employed. And so they didn't need to be building or didn't want to be building with timber framing anymore. They had conventional homes, 2x4, stick framing, like all that stuff, sheet goods. And so it died out, and it wasn't until maybe the 60s when this kind of back to the earth movement, back to the grass movements came around, they wanted to know, well, how can I build a more, let's say, sustainable or back to the earth structure? And they often looked at barns. Timber framing people or carpenters or just people just looked at barns because in America, the barns were where, again, generally speaking, is where the timber framer can really show off their skills because it's all exposed. And so they would probably, examine these barns and look and say, okay, you see how these two pieces go together. They got a mortise and tenon, they got these pegs, and I'm going to copy this. And I'm going to kind of do that. I'm going to apply, and I'm also going to apply with what I know and a lot of what a lot of carpenters knew were more joinery related stuff, like cabinet making. And so a lot of cabinet makers started becoming these timber framers. And then they started just applying what they knew, which is totally normal.
Smaller scale is still joinery.
Well, the timber framing started to become like large furniture. Whereas it never ever was that until fairly recently. And again, like it's kind of uniquely in America that we have this mentality of timber framing home is this large piece of furniture.
Yeah.
Well, the other countries, or the rest of the world is
carpentry.
It's carpentry. It's timber framing. It's the wooden structural skeleton of the building that's meant to hold up the walls and the roof, but it's not this aesthetically like piece of furniture like this table or this chair is. You know? Yeah. Yes, and again in other applications it is, but generally it wasn't.
So go back to Japan in about 10 years, and you'll probably see a true lock bolt.
Yeah, for sure.
Screw, right?
Oh yeah, for sure.
But I guess I want to talk about engineering because there's structurally sound timber framing as well too. So anybody who's building, you still got to have some sort of engineering understanding of, I guess, strength. Right?
Yeah, for sure. Mm-hmm. Yeah, but depending on where you're building and who you're building for and the size of it, it's always a good idea to get a licensed engineer to look at it, and if they're competent in that area, then they can approve it or they'll stamp it off or whatever. Yeah,
because there's a whole other, I guess, engineering table that's associated with certain specific timbers, beams and things like that, structures. I remember talking to the Caledon timber framers, right? And they were talking about that, how the strength of a Douglas fir beam from out west, and what you're allowed to do, how big you can go out, span
tables and
all that stuff, right? So that's all associated with that. So it's the same thing. As much as you're drawing it on paper and you're starting it, you still have to have a mindset of the engineering portion
for sure.
of it, right? So, and same with barn, I guess, but with barns, I'm not saying that it's easier. It's just barns were designed to go into a center or intersect, right? So then I guess the strength of pushing on one side was pushing to the other side, and that's how you kind of connect the two together, right?
I don't really fully understand what you mean.
Well, when you had, I guess you're building your roof structure on a barn.
Yeah, like the triangle.
Yeah. Your engineering, I guess, forces are onto each other, so they're holding each other together.
Well, it depends on how it's designed.
Yeah.
Yeah. So, I mean, as you're roof, if it's a triangle and you apply pressure, it wants to spread out.
Yeah.
So
you have a collar.
You have a collar tie or a tie beam.
Yeah.
Yeah.
So then that you're basically, I guess, you're balancing one side to the other. I'm not trying to oversimplify it.
Yeah, you're just tying in this triangle. You're making triangles.
But when you start getting into other structures that have whatever rounded roofs or peaks roofs or
arches and stuff,
and all kinds of stuff like that. I mean, it's still fascinating to find out where the history of coffered and all kinds of things like that. So it's like that's when it starts to become very, very challenging.
Yeah, it can be. Yeah.
So that's where it's like, as a kid, you're coming in, or a person that's coming into this industry. Yeah, sure. Okay, you're starting. Let's say with this one, you're starting with 1/4 or whatever, but now you've got to build the rest of that,
Yes.
and then get it together.
Yeah,
there,
exactly.
Right?
Yeah, just baby steps. What's that? The expression of do you know how to eat an elephant? Do you know how to eat an elephant?
Oh yeah, just one
bite at a time. Yeah, you just take it one bite at a time. You just do one thing, one thing at a time, and it enables you. By doing all these little baby steps, it gets you to the finished product of what seems to be maybe an overwhelming or a large project or something like that.
I'm still pissed off that you had such a hard time trying to get the educational friggin' system here to embrace or even understand this.
Well, it's not even there yet. It's still not there.
It's not, and that's what I mean. After nearly 10 years, it's still not even there.
Yeah.
It's missed opportunities. That's why
totally,
at the start of the show, I was like, Japan, Germany, and France, and Canada can be a part of this. And even the U.S. could be a part of it.
Totally.
Mexico could be a part of this.
For sure.
And I would love to see it be a part of it, right?
Well, I mean, you ever heard of the World Skills Competitions?
Yeah.
Skills competition?
Yeah.
So, I mean, we have it here in Canada and the U.S., but they have the World Skills Competition. So if let's say you win nationals in Canada, if you're under a certain age, I think under 25, then you can go and compete at the world event.
Wow.
And we just don't ever have competitors
to go
because often they're older. But also when we have sent competitors, they're completely lost.
But in all fairness, Pat, I mean, is age really an issue here?
No, of course not. It's not. But in the World Skills event, like the Olympics, for them it's...
Why can't we have an older person?
What's not? Yeah, let's do it. Why not? Yeah.
Why can't somebody that's maybe at the peak of their construction career who has a new passion for this, doesn't matter if they're 20 years older than the limit,
exactly.
Go and represent?
Yeah, no,
that's another. Me and organizations and rules, man. It's just, they don't get it together, right? Yeah. So it's just, I would love to see more of this in the educational system.
Me too,
right?
For sure. And it's coming. It's coming. Inevitably, it's coming. And as a young kid coming up, you'll see it.
Yeah.
Yeah. And if it's not, I'm not saying that because it's me or anything, but you'll see it through someone somewhere. Someone's going to show you some of this stuff. Because it's getting out there. And for example, I have a couple of students that are instructors. They're teachers, and that's what they do. And they teach carpentry full time, and so they're integrating this stuff into their programs. Wow. But as any, I think, let's say government funded program, it has to be approved, right? If you want to be government funded
by people that don't even know construction to begin with, right?
Yeah. So because the industry often dictates or funds and pushes the educational part of it, right? Because if the industry is demanding for certain skill sets, well then the schooling system better produce students with that skill set. So then when they get out, they're employable, right? They're employed.
Yeah.
So
I see what you're saying.
So if in some ways the industry is not demanding for it, the education system will never kind of teach it. But beyond that, outside of that, there are instructors that are taking courses. They're actively doing them, and they are integrating these into their program on their own.
Let's talk money. Like career-wise, sure, obviously this is a passion and everything like that, but still, if someone's getting into this, is it lucrative? I mean,
what do you mean? How, like,
everyone always, I always argue the point, there's the big three in construction, which is HVAC, mechanical world, plumber, and electrician. They're the money-making career options in construction, right?
Okay.
So they're also recession-proof and everything like that. So everyone gets into their trade because of, I guess, passion and interest, and this is what they love to do. But there's also still, it's a living. I'm making money from it. Mm-hmm. So as much as this is passion and I love it and I want to do it, but I mean, can you actually make a career out of it, financially speaking?
Well, you might not make a career out of this specifically, but you'll make a career out of in the trade using this knowledge.
Using the technology.
Yeah, using this knowledge.
The knowledge. Yeah.
So, I mean, for example, with the company that I work with, if you could pull it up on the Instagram.
Sure.
We did this very elaborate project where I used this. So if you want to scroll down, I think it's closer to the kind of the beginning of when I started on the Instagram stuff. It's basically an entranceway to the U.S. Embassy in Ottawa, and the old U.S. Embassy in Ottawa. It's an entranceway that looks like kind of a contemporary wigwam, like a Native American structure, like longhouse kind of thing. Yeah, and this structure employed these these in-house glue laminated timbers, these kind of like rib looking things that look like a boat kind of.
Yeah.
And the way this project came about was an architect came up to us. They had these preliminary drawings, or let's say conceptual drawings that they proposed to the client, and in this case, it's the government. And they said, well, we want to build this structure for this building, the old U.S. Embassy, which has been converted, or I think is converting into a Native American museum for the Nations Museum.
Okay.
And we had literally two drawings. We just had a plan view and an elevation view of this like really weird looking or like really interesting looking thing. And they said, they asked us, like, can you do this? And my boss came to me and he showed it to me and goes, can you do this? And I said, yeah, we could totally do this for sure. And I'm getting to your question about, can it be lucrative? Yeah. So we got this wonderful project that we made lots of money on because of this knowledge, because I had the skill and, I taught the guys that I work with some of this information that enabled us to build this structure using these drawing techniques. So it's lucrative in that way that you're using it to build a structure.
But you can also do that as if you're a business. Everybody's self-employed, so they're entrepreneurs in this industry. Mm-hmm. It's just another tool in your.
It's just another tool in your tool belt. Yeah, it's not the end all be all.
No,
it's certainly not that.
But it's definitely going to open up opportunities
for sure, and especially if you get interesting clients that want interesting designs or something, then you have this ability to do that. And it's above the standard or typical forms of conventional forms of construction.
Yeah.
Yeah. Which is cool, but
how else are you promoting yourself, Pat? Like to get the word out there?
Being here,
just so being on places like this, and then also on social media.
Social media, yeah.
But I guess just the word of mouth.
Mouth.
That's all it is.
The workshops, those are big ones, and my students, those, yeah.
Yeah, there's the whole Kevin Bacon 6 degrees because Fred got me to you.
Right, exactly.
And obviously other students are probably going to hear it as well and
start
talking about it, right?
Mm-hmm.
And I would love for other people, other students, or other kids from other countries, like, I just listened to this and I was interested in get them on the show and start talking about it. I'd love to interview somebody from France there, from Japan, from Germany, or whatever, right?
Yeah. Mm-hmm.
And get more of this conversation because I am totally in love with this stuff. I mean, it's maybe one day I might tackle it myself. I'll try to figure it out. I'll figure out that umbrella one day.
Yeah, exactly.
Right?
Yeah.
But I mean, it will be a challenge. It's no different than like 15, 16 years ago when I was tackling crown molding for the very first time.
Oh, okay. Yeah, that's
how I freaked out how to friggin' do it until I figured it out, right? Mm-hmm. And I'm talking about wood crown molding, right?
Right.
So, and now that I know how to do it, it's easy. It kind of makes sense to me, right?
Right. Well, I mean, that would be the basic forms or basic notions of this stuff. Yeah.
I'm not like nowhere in the same school as you guys.
No, it's all good. That's most like mainly people get interested into it when they start doing crown molding, stairs, roof framing. That's when they're like, okay, now it's kind of getting beyond my skills or what I've kind of get taught.
Yeah.
Typically. Yeah. Yeah.
Are we anywhere near finding it or
getting
not?
there? Yeah.
Getting there? How far back are we going here?
Probably, yeah, it's a little ways, but.
So this is you got images of you actually just drawing, scaling. So
yeah. So like on the Facebook page or Instagram, there's like, this is all just workshops and all of this knowledge being used. I mean, there's hundreds of examples from models to real life things to, you name it, of people using it. So a lot of it's my students. Others are from people in Japan, Germany, and France. Really just to show people that this is what you can do. So for example, like if you stop right there, the second image in from your mouse, you have this like go down one right there.
Okay.
Right there. Click on that, please. Yeah. So there's a model. This is a reframing model. You can see in the background, you got stairs in the back. Then even further back in that picture, you have windows for joiners. So this model specifically, if you go back to the previous image, one maybe to the right, I believe. Right there. That's the drawing for it. So this drawing is what...
Go back to the image of it. And that's... Okay, now go back to the drawing. That's the drawing that you drew first.
That's right. Yeah. Not me, but somebody else.
Okay, well...
Yeah. So
now I'm back into intimidation land. like well, look at that. I get what you're saying about drawings.
But this is what's called a stereotomical drawing.
So I'm on top looking down.
In fact, you're looking at a multitude of things all at once. And that's what makes these sorts of drawings so unique, is that you have all at once all of your information. So like the analogy I give often is, if you were to have a novel, like a book, and you were to somehow compress all the pages onto one page, the whole story is on one page, but you have to somehow decipher it. And it's the same thing that you're looking at here, where on this drawing, you have a plan view, you have elevation views, you have individual component views, all on one drawing. And it's on that drawing that enables you to build that model.
What are the pink lines?
The pink, so there's so many different, like I'd have to look at it, but it's often the pink is associated with what's called a footprint, or a section cut of a piece at a certain height. Yeah.
Let me see the picture again, Angelina. Yeah, I'm still not connecting it.
Yeah. Well, so see on the right side, you have a round.
I see that. That's the only part that I actually got. Yeah. But I see that you've got like a dormer or entry on the middle section. Mm-hmm. Then you've got a curve peak on the left section.
Yeah. Yeah.
Like, could you make it harder, Pat? Man.
Well, man, this is when it starts getting interesting. And then it goes far beyond this. It just doesn't end here.
But it's fascinating that there's actual structures in the world that have...
Oh, yeah, totally. Yeah, yeah.
It's fascinating, man.
So I was going to stop. So the picture...
that's fine.
Yeah, the picture right there, you see this guy's face wearing orange. Yeah, that's Nathan Grunwald. He's one of the best students I've had. And in the back there, this is for his professional certificate, or his advanced professional certificate. And he built this in the back there. You see all these curved elements.
Yeah,
that's what you're looking at. There is what we would see as a groin vault, and he built this for his entranceway at his house, using all these, like literally these 3-dimensionally curved pieces. So you can think of it as like a roller coaster. You know how a roller coaster goes up, and then as it goes down, it swerves and goes around, and it does all these crazy things. That's what he's done with this wood, is that he's taken this large piece of wood, like a stone carver does, and out of that big block, he cuts out these curves very precisely to his lines in all ways. And now you have this 3-dimensionally curved piece.
So I'll speak a little blasphemous, because I've seen some stone guys get into 5-axis
CNC. Yeah, that's pretty common.
Is that cheating now? Is that like...
No, I mean, so there it is right there. Sorry, the photo on the right side, right there, boom.
That's his ceiling there?
That's his ceiling there.
Holy cow. I love groin ceilings.
So that's called so that's a groin vault that we would probably see, but more accurately, we would see this as carpenters or timber framers. We'd see what's called a capuchin. And so he used 4 of these capuchins to make this vault. So
technically speaking, for it to be labeled a groin, it means that it comes from 4 different directions?
No, I think it's just 2. A groin is when 2 barrel vaults intersect.
And it creates that intersection.
That intersection.
But sorry, you said that the actual terminology in timber is considered, it's what?
Well, in this specific case, it's called a capuchin. A capuchin. Like cappuccino, capuchin.
Italian origin?
Probably Italian, but French for sure. Capucin in French.
Got it. That's beautiful.
Yeah, so he spent like 800 hours or something on that thing.
That's pine, huh?
No? I think it must be pine, yeah.
I'm looking at the nuts. That's why I'm thinking it's pine. But, okay, that's beautiful. Yeah. And he built it as... So he built it as one, but there's... Okay, how did he build that?
In individual components. So each one of those little like curved X braces are individual pieces.
Yeah, like look at the way the curves intersect to each other.
And if you look closely, you could see this half flap joint between those 2.
Yeah, that's what I'm looking at right now. How did he draw that?
That's this drawing technique. That's stereotomy. Is that by drawing things out, it enables you to solve for all of that stuff. You could solve for everything or anything.
That's absolutely insane.
So this is the stuff where it's like, if you want to say it's lucrative, well, you can do these sorts of things and you can charge for it.
That's his entrance too, huh?
Yeah, it's his personal entrance. Yeah.
And look at that. He opened up the soffit.
Yeah, beautiful. Yeah. Copper flashing. There's a few photos there. Yeah, it's beautiful. Exceptional. I mean, it was, hands, hats off to the guy.
The guy did a really good job.
So you can see some of the components there.
No, I'm not questioning the actual financial component attached to it. I totally think that if you actually offer this and you have it, the clients will come.
Oh, for sure. Yeah, exactly. I mean, if you just look at all those photos, I mean, this is where, you can see these big chateaus and castles and staircases, and well, that's what you use. That's what you do to build all of this stuff.
Let me see the pergola there, about in the middle, right? Yeah, there.
Oh man, well, you got to look at when it's completed. It's way better. He's got a twisted spire on the top of that.
He's got
a spire that's twisting.
Where's the completed image?
It's probably up a little bit there. You have to. Yeah, keep going.
So he twisted the actual peak?
Yeah, exactly. It's called a twisted spire, and there's a whole. There it is, right there. Boom.
Because that wasn't challenging enough, huh?
There it is.
Look at that thing.
Slate roof, copper flashing.
Where was that?
That's in France. That's this guy's masterpiece. So in France, with the traditional system, if you want to, what we would think as graduate or finish, you have to present a masterpiece. And this is his masterpiece.
Well done.
Yeah, for sure. He spent like 1,200 hours or something on this thing.
I totally love the twist there.
Yeah.
Like it would be beautiful on its own, but that twist just does something else to it. And slate as well too, and then completely open on the inside.
Mm-hmm.
That's crazy, man. I love it. Let me talk a little bit of building code here. What is the building code for beams in Ontario? Beams shall have even and level bearing, and shall have not less than how many inches of bearing on end supports? I actually know this just from regular construction.
I would say it's 1.5 inches, 2 inches.
It's 3.5 inches.
3.5.
Beams. But if it's actual just joists, it's 1.5 inches, which I'm still stunned that it's only 1.5 inches. But beams are 3.5 inches. Table A8 to table A11, lap not less than 4 inches, and clamps such as between framing members, furring or blocking, and rigid panels. What are the minimum nailing requirements for built-up wood beams? I've done this before too. Yeah. So it's 1/2 inch diameter bolts. I've actually done it. I was asked to do it every 24 inches, but here on the code, they're saying 3'11" is max. So obviously, yeah, ideally they're recommending 23 5/8. How wide can a wood beam span? So we're going back to regular, I guess, tradition, right? So
I guess it depends on the size of the beam.
Yeah. So a wood beam span depends on the modulus elasticity size and load it has to carry at 4 inches by 10 inches. Number 1 yellow cedar beam, which has 1,400 kilopounds per square inch. That supports a uniform linear load of 80 pounds per foot. Can span 17 feet. Now here's just a table just for 2x10 beam span. So a 3-ply 2x10. How far do you think the maximum span is for
3x2x10?
Yeah. Sorry, 2x8. 2x8.
2x8.
3-ply 2x8.
15 feet.
10 foot 7 inches.
10. Okay.
3 2x10s maximum is 12'9", and then 3 2x12s maximum span is 15 feet.
Okay.
So
yeah,
I actually came across that in one situation. I need to figure out.
I think with the code, this is a question I brought up about to some of the timber framing engineers so the minimum, that's when it starts to deflect too much.
Well, the deflection I don't agree with.
Yeah, exactly. I know exactly, and I get it. Wood can really deflect before it fails, right? I mean, you can really load a piece.
Almost up to an inch.
Exactly.
They are allowing.
Well, it depends, yeah. The old school, like farmers, they would just load their the hay loft until the beams would start sagging, and then that's when they would stop. So it really has to deflect before it starts. Then it structurally fails. But from their perspective, it structurally fails when it's too much of a deflection. Yeah.
I love walking into clients' homes and walking into their massive master, walking on that floor, and I pray that they have a dresser with handles on it.
Okay.
right? So like dangling handles on it. So then as I walk, I hear those handles rattling.
Nice.
So I'm like, there's the deflection for your house, right? Which is absolutely, which is code. It's minimum code. That span is actually totally legitimate. They allow it, but
There's also some spring to it.
there's a little bit of spring to it, which I don't agree with. But
Yeah.
what else do you want to talk about here, man? Like, I mean, these projects are fascinating, and I'm not. Trust me, I'm not disputing you that you can make this a very viable career option, man.
Well, I mean, it's just you're integrating this into your career, into your livelihood. So I don't know, like let's look at that photo of that gazebo right there of the pool. So on the left side there, right there, boom.
Wow.
This is a Carolina Timberworks. I shouldn't say anything because I don't know for sure, but this is a project that they've designed and built, and it's like, well, this is what you can do.
That's slate.
Yeah, I think so. Yeah.
So what I'm looking at, I mean, even if it's Carolina, but the thing is, that's going to last a long, long time.
Well, as long as there's a good roof on it.
Which is slate.
Yeah. Yeah, as long as there's a
leak.
leak.
And the peak on that, that'll always shed weather.
Yeah. So what you're looking at there is, for people who are just listening, is in the center you have an elliptical structure on plan view, but also the ridge is elliptical. So what's happening there is that your roof pitch remains the same as you go around this ellipse. And that what gives you that curved ridge. And then on either side, kind of flanking either side of this ellipse, are these two turrets, conical in shape, that are kind of coming on either side. So it gives you these curved valleys. So if you I know you want to talk about skill. If you want to stand out in terms of skill set, and you can come and say to your client, look, this is what I can do, there's value there.
Oh, 100%.
Yeah. And it's not just the framing or the roof framing aspect of it, although that's what we've seen. It's further than that. There's more to it than that.
But these techniques are also being used in furniture making as well.
Exactly.
Too.
Oh yeah,
Legs
for sure.
Like
Yeah,
that,
yeah.
right?
Actually, just recently, there's a student who's doing his, I believe, his PhD thesis, and he's doing his dissertation, and he contacted me to talk about how this stereotomy in furniture design. And this is coming back kind of full circle to butting my head against the kind of in America is for years I've been trying to contact publishers to get, writing a book or writing articles and stuff like this about this subject material. And I contacted one publisher that they publish furniture making stuff, design, and telling them, look, like there's this sudden knowledge stereotomy, blah, blah, blah. Let's work together to get a book out. And they basically said, no, we're not interested because our readers are mainly furniture makers. And I'm just like, man.
But the principles are there.
Exactly. And then, then now you have this student who's doing his doctorate thesis or master thesis, and it's about stereotomy and furniture design. And you're just kind of like, yeah, you just.
So are there not any books right now out there?
Well, there's a little bit in like Old English. So let's say back in the 1800s, there's, guys like, let's say, Peter Nicholson, James Newell, who else?
They've written books.
Yeah, they've written books, but coming out of England in the UK, turn of the century, 1800s, 1900s, that talk about it, and they have some aspects of it. But none of them get as far deep as, let's say, the French go. For whatever reason, the French have kind of took this thing and went to the extreme with it, and went all the way to the end. And no other culture has done it other than the French for some reason.
So is there anything in Quebec?
Historically, there's a little bit of things in Quebec for sure. But again, in the American context, we have to understand the history of how this country was, founded or whatever, how people were coming over. So when, immigrants were coming over from Europe, again, generally speaking, they weren't the most, let's say, intelligent, well-to-do people. A lot of them, in fact, most of them were poor farmhands, uneducated poor farmhands that couldn't read, couldn't write. And in some ways, instead of dying at home, well, go to America, go die in America, and in the meantime, try to make something of yourself. And so our kind of mentality in construction, certainly then, and in some ways it still continues today, is we want to build as fast as we possibly can, production, right? And historically, we needed to build homes quickly, especially a barn. because that was winter's coming. We got to, we got to get the food in. We got to store some stuff. So we need houses like yesterday. And this continues today in the form of this productivity. In my opinion, I think we overvalue productivity. Yes, being productive is certainly important in the industry. You want to do things quickly and efficiently, because you want to make your money for sure. But I think when you want to take a step back and look at society as a whole, it's not very holistic to say that or to value just production. That's like an industrial mindset is, well, what about the people themselves? What about the people, the consumers, or the people living in the society? It's important that they're healthy as well.
Yeah.
And so, this knowledge taps into this more holistic approach of technology as opposed to this, what some people consider prescriptive technologies.
Yeah.
Yeah. There's a really good book called The Real World of Technologies by Dr. Ursula Franklin. And she's passed away, unfortunately, but she taught out of the University of Toronto. I think in anthropology or something like that. And she talks about the real world of the applications of the real world of technology and how in our system, we have this, what she considers prescriptive technology, where think of the classic assembly line. Ford Model T, Ford came out with this system of, manufacturing the vehicle where you have, let's say, an unskilled person doing one task
for every
and then this thing goes down the line and everyone just applies their one thing, and then out come the assembly. At the end of the assembly line comes this really elaborate, very complex system, a vehicle, right? That's prescriptive technology. And what ends up happening with prescriptive technology is what she found with her research and all that stuff is that it ends up empowering management. And so managers and upper management have the power through processes and procedures for industrializing and making things more productive. And that's how they can then control this system. Whereas there's this other form of technology that she considers holistic technology. And the, let's say, classic example I can give is a craftsman or a craftsperson, the artisan, where this one person has all of the skills required to build something from A to Z.
Yeah.
So as a furniture maker, let's say, you have the ability to go to the woods, cut a tree down, you examine your wood, your wood, you cut it down, you mill it, you do all this stuff. And at the end of the day, you have this very refined piece of furniture. That is the holistic approach, because you have this one person who's skilled in every aspect, and they have the entire control of that process. And so holistic technologies ultimately empower individuals, whereas prescriptive technologies ultimately end up empowering management.
Yeah.
And so you have these two very different contrasting systems that, they're both, there's good applications to the both of them. I'm not saying one's better than the other, but it's not that we should look at one as being far superior than the other.
We should have the option for both.
We should totally, and we should also encourage people, and through through schooling and through people and clients demanding this sort of thing of holistic technologies. Of you have an artisan who makes from A to Z. I do this whole process.
I'm not disagreeing with you, man.
No, yeah,
I'm listening to it, Pat, and I'm like thinking, okay, so what's it going to take? Because I assume that you're traveling all over the place and you're doing these classes, or you're doing online classes as well. Mm-hmm. You got to kind of set up every time you travel and then do the course and teach and all this other stuff. But what's it going to take for you to actually just create a home base and just go here?
I do.
That's what you have.
I have a home base as well. Yep.
Yeah. So you have the shop as well, right? But I mean, to make this shop grow and grow and grow and get hundreds and thousands of kids in there.
Yeah. I don't have that as a goal. That's not something I want. I don't want to build something where I'm now the next industrialist, productivity of pumping out these kids.
Yeah.
I don't know how, if I knew all the answers to these things, I'd be probably a millionaire by now. But I think in some ways it's just keep doing it and keep, go traveling and get this knowledge out there.
That's all you want to do, is try to get more and more people interested in knowing that this is out there, first of all.
Yeah.
And second, that you can actually use it.
Yes.
And then third, you could probably make a career from it.
For sure. And just how practical in empowering this stuff is to people. Yeah. Because you're not, ultimately what you're doing is you're not subscribing to a technology. You're not buying AutoCAD. And if I want to design something, I have to use AutoCAD. That's great. And it's wonderful. And I'm not dissing it. Or like a CNC machine. Like those are all wonderful tools. They're great tools. But I think we have to be mindful or at least conscious of, well, then we become limited to that tool.
Yeah.
And I think as humans, we don't want to limit ourselves. We have this like innate desire to do things that come from the inside. I don't know, I'm getting a little maybe philosophical there, but where we're not confined by it.
Yeah.
This knowledge is, again, going back to the beginning of the conversation, this knowledge is ultimately the only thing that's limiting is your own imagination. The tool itself, you can use the technology, that's great to manufacture or build what you want, but you still have this understanding or of the design or of this object, this three-dimensional object. And that's the ultimate goal. I mean, is how do we practice that mindset, is that mind skill.
I'm just species of wood. What are you guys using mostly? You guys
in timber framing?
Yeah.
Pretty much. There's lots of fir, pine, oak, spruce.
Oak.
Yeah, white oak, red oak. I mean, cherry. There's all kinds of species that you can use.
Yeah.
Yeah.
History speaking, what was the go-to?
Well, it depends where you are geographically.
So Japan and Germany and France?
Well, so in Japan, I think it's a lot of this type of cedar.
Okay.
Or there's another name for it, I forget. And then in Germany, in France, mainland Europe, a lot of pine, a lot of spruce, a lot of oak, beech. In England, lots of, white oak now because they get it imported from France. But and then here in America, historically, we would just use whatever that was around us. You know, if we were building a home, we use whatever the forest had. Yeah. But in the kind of, let's say, more in the industrial end of timber framing, I think pine and fir. Yeah, spruce, pine, fir. Yeah, SPF kind of stuff. Yeah.
I'm fascinated by this, man. So if anybody wants to get a hold of you, just do it through Facebook.
Yes, so social media stuff.
Social media, School of Stereotomy, and then but you can also try the website as well too. But mostly through social media, right? Mm-hmm. A little bit of Green Book talk as we get close to the end, but not quite. What safety procedures should you follow when using woodworking machines? I guess timber frames, you guys are still using machines.
A lot of hand tools, so
everyone knows. Always wear safety goggles, face shield, dust masks, hearing protection. That's a big one now. You kids that are younger, you're going to see your ears, man. If you don't pay attention when you're younger, you're going to see your ears, right? So working, operating, woodworking equipment suffer the following common injuries: lacerations, amputations, severed fingers, blindness. We all know that. It's all the good stuff.
Oh, yeah, exactly.
What precautions should be taken to make a safe environment when working with woods? Woodshop safety best practices for working with your hands. Gear up. Stay alert. Always remember to disconnect, declutter, avoid using dull tools, handle tools properly, keep distractions.
Dust. Watch
That's
the dust.
It. And dust,
Dust is a big one now.
Listen, I'm not even a fan, but recently I just did some work and I was forced to use MDF trim.
Oh, yeah.
And it just reminded me 1,000 times why I can't stand MDF. And I was coughing and breathing and MDF, I just can't stand it. I hate it. Yeah. I actually breathe a lot better. Not that I should be, but poplar.
Yeah, well,
pine and it's a lot easier.
I mean, ultimately, any dust isn't good for you.
No, it's not.
And there's certainly some.
But I had such a new hatred for MDF.
Yeah,
absolute new hatred for it, man. So, Pat, what else you want to share before we get close to wrapping it up? Because I'm fascinated. I mean, we could look at all these different.
Yeah, for sure. I mean, there's a lot we can talk about. I mean. So one of the things
I'm not ready to shut it down.
Okay, cool.
We got plenty of time here, man. So, yeah.
One of the things I'll share then is, the question that I often get asked about this stereotomy stuff is, well, why not just use a computer? We have the technology. Why not just use a computer? And certainly, use a computer. It's good, and that is a tool that we should certainly teach people. That's because that's part of the industry, and that's what everyone uses, and that's important to know. However, when you're first learning something, you do want to be using your hands. And there's a lot of neurological reasons why we you would want to use your hands when you're first learning something. One of the main ones is there's a study done by these two professors, Pam Mueller and Dan Oppenheimer, coming from, I think, Harvard and Princeton, or Princeton and the University of California or something like that. And anyways, they did a study about note-taking by hand versus using a laptop. And so this is going to come back to what I'm saying here. But what they discovered is, they did this research, and they were looking at how well did the students retain the information, how well did they synthesize it, how well could they, perform on a test. And what they discovered is the obvious, is that taking notes with a laptop, the advantage of that is that you can type as quick as the professor was speaking. So you have a tremendous amount of notes that you can refer back to. Your notes were almost a copy of what the professor was saying, verbatim. And whereas the note taking, you couldn't write. Most people can't write as fast as we can talk. And so your brain is forced to take this information, and synthesize it, or somehow kind of understand and then make point form notes. And it's far more work mentally and also just physically of writing this using this pencil. But neurologically, what's happening is that far more parts of the brain are engaged when you're writing than you are with typing. When you're typing, a lot of the brain activity is silent because you're just paste. When note-taking, you have not only just the listening and trying to synthesize this information and then make point form notes, but your tactile hand motions is engaging other parts of the area of the brain that is further ingraining what the professor is talking about. So when it came time for the test, most students, or students who took the notes by hand, generally outperformed students who took notes on the laptop. And so when it comes to this, when people ask me that question of why not just use a computer, is because when you're drawing something by hand, far more parts of the brain are engaged. You're retaining this information. You're having a true understanding of what it is that you're doing. And it's kind of like our brains are primitive. We're species that are really, really old, that technology is like outsmarted us, in a lot of ways. And we can't, evolutionary speaking, we can't keep up, right? So our brains are meant to be living in the 2000 BC, right, with that technology. And that's how our brains adapt and evolved in our environment. So if you want to have a real understanding of something, you have to generally just use your hands, do it by hand. And you'll see that it's certainly in some ways a lot slower, because learning takes time and practice and effort. But at the end of the day, you have a far better understanding of the material. So when it comes to this sort of stuff, it's drawing it by hand. And a lot of professors, they're seeing it now too with students of taking things by hand, note taking by hand or typing. But I think, in architectural schools, they instantly just go to the computer and start drawing, drafting things up using AutoCAD. But there's still some good universities that if you're wanting to learn classic architecture or something, the beginning courses are, how do you create an ionic capital? And you're going to draw this by hand. And you can use all the geometry that's required to do this to get the proper proportions and the proper heights of the frieze and all these things. And so now that student has a really good understanding of what it means or what it takes to design something well proportioned. Did
you go down the architect path along with the schools, or was there any interest from there?
In France, a little bit. So we learned a lot of, but timber framing specific related, in learning the different designs and different architectural elements of half timbered homes in France and in Germany.
Okay.
So there's some courses on that. Yeah. But it's not something that I was, I'm getting more into it now, but when I was first going through it, I was more that, let me cut something. I want to cut the rafters, or let me do the actual physical work.
Yeah, no, it wasn't so much that. It was actually speaking to architects that wanted to implement this into projects.
Oh, for sure. Oh, sorry.
Because they'd be another sounding board, right?
Oh,
out
100%,
there.
yeah.
But were they like the school system where we really don't?
In some yes, and others no. But I've had multiple architects students come through, and they're working professionals. They come and take a workshop because they're curious and they want to learn a little bit more of the stereotomy stuff and how can I, what does it really mean and how can I imply this into my design?
Yeah.
And yeah, it's it's awesome to have them because they bring all this massive sea of information that I don't know anything about, in architecture. But they go back, they learn this thing and they go back and they try to implement this for craftspeople. So come full circle is that now this industry is demanding it because you have people designing it because they're proposing it to clients like it. Now we need the skill to build it. And so then now here we are. Okay, build it. Well, a lot of contractors, I can't because I can't do it with my framing square. It's beyond my skill. It's beyond our wheelhouse. So whatever, I can't. So then it doesn't nothing happens.
So nowadays, right now, if you do have a client or an opportunity, they'll have a harder time trying to find somebody to actually do it.
Yeah, I mean they can. Yeah, but
you'll find somebody, but you'll have to have to search that person, right, to find that person.
Yeah, right now,
right? That's the thing about it.
Yeah, but give it a decade.
Hopefully.
Well, I mean, yeah, maybe I'm just being super optimistic about it, but
I hope so. I hope you're totally right. I mean, I hope that in a decade's time, there's tenfold amount of people that are in actually practicing this in the industry and actually offering this as a skill set for their wheelhouse, right?
Yeah,
totally would love.
Well, I mean, I've been going around the world teaching employees to companies. So a company will hire me to come in and teach their people this stuff, and then now they have skilled people that can do this. Yeah. So as that continues, more and more people are going to be able to do it.
All the best to you, man. I'll share what I can and keep me updated with all kinds of stuff, and I'll keep on sharing more and more stuff out there. I'd love to get more and more, even if your students or anybody else that's interested in getting on the show and sharing their story as well too. By all means, love to get them on the show, right? So we can talk more about it, right? So again, reach out to Pat on Facebook and IG, School of Stereotomy, and then also, sorry, how do you pronounce it? Yeah, I'm not even going to...
The Stereotomist?
The Stereotomist.
Yeah, on Instagram.
And then on the website there, you can reach him as well, historicalcarpentry.com. And I guess the side gig is... we wanted the Professional School of Practical Stereotomy.
That's right.
Ready for the 12 questions?
Let's do it.
What's your favorite construction word, Pat?
Stereotomy, man. What do you think?
I actually love the word now that you shared the whole dissection of it. What is your least favorite construction word?
Least favorite? Probably... a lot of swear words because it's a lot. It just indicates a lack of vocabulary for me.
What turns you on in construction?
The ability that we make something out of nothing in some ways. We have a set of plans, and out of those plans, we realize physical environments, and that's very empowering. I find
it is. It is. What turns you off in construction? Nothing?
Well, no, I'm thinking there's a lot of stuff,
It's like one of those, huh?
Yeah.
They're far and few.
Yeah. I guess people that, I don't know, man. What turns me off construction? The stress, maybe.
Yeah, there's a lot of stress.
There could be a lot of stress, and scheduling, and so many people can be involved, and other people's egos.
Is it self-inflicted stress?
Yeah, man, totally. I know, for sure. Yeah.
There's always 3 ways to do it, right?
Yeah.
What's your favorite curse word? Well, you don't curse. Do you curse?
Oh, hell yeah. Fuck yeah.
So what's your favorite curse word?
I mean, obviously fuck.
The go-to.
Yeah, obviously.
The
it's
classic.
So versatile. Yeah, you can use it in any context.
What's your favorite vehicle? Anything in the world?
Favorite vehicle? Man, I don't really have one. I drive a Toyota Yaris. So there it is.
What's your least favorite vehicle?
Least favorite vehicle? Man, I don't know. That's a good one. I don't know, man. What's yours?
My least favorite?
Yeah.
What did I choose? Corolla.
A Corolla? Oh, yeah?
A Corolla.
They last a long time, though.
They're all over the world.
Yeah.
Every single country.
Yeah. The Taliban use it.
Do they really?
Well, they use Toyotas. Yeah. I mean,
they use the pickup trucks, don't they?
Yeah, they do. Yeah.
I remember watching, what was it, Grand Tour or something like that? And
okay.
they were doing a militant version of the go-to pickup truck.
Oh, really? Yeah.
So that was kind of funny,
yeah.
but.
Okay, Corolla. Really?
Corolla.
Yeah.
You don't have one, no?
I don't know, man. Maybe something like some shitty thing that doesn't last long,
Hyundai's been mentioned quite a few times.
Okay.
way back then. You're too young. You know.
Yeah.
Yeah, you know.
Yeah.
Well, no, the Hyundai ponies of the day.
Oh, okay.
Back in the day, right?
Okay.
No, if you don't have no big thing, man. What construction sound or noise do you love?
The sound of a pencil on paper, drawing away, nice and quiet, calm. Yep.
Or on MDF?
Or on MDF.
What construction sound or noise do you hate?
Oh man, the machines. Yeah, when you gotta wear hearing protection all day long and the vibration of it.
Loud nowadays,
Yeah.
man.
Oh, it's so loud. Yeah. Chippers.
Yeah.
Chippers, man. That'll get to you. You'll go crazy.
Piercing.
Generators. Electric generators. Like when all those vibrations are on all day. Day after day, week after week. You feel it. It's in your chest, and when it turns off, it's just like
I love how the marketing guys always talk about how the DBs are not that loud on these units, and I'm like, they're damaging loud. That's what they're loud.
Yeah. And if it's not even the DBs, they still have low DBs, but low frequency that's damaging. Low frequency is just as high frequencies that can be damaging to the ears too.
So kids, wear your hearing protection. I don't care, man. Get them. Buy a good set.
Yep.
Get them. What profession other than your own would you like to attempt one day? Well, you're doing 2 right now, but I guess
teaching and super. Maybe something more physical like jiu-jitsu or something.
What profession would you not like to do?
I don't know, man. I don't know. I would say like in terms of construction, laborer. I don't want to be a laborer.
Laborer.
Yeah, I mean, like chipping, demolition work,
digging,
hauling. Lots of, you're killing your body over time. Yeah.
Last question: if heaven exists, what would you like to hear God say when you arrive at those pearly gates?
Oh my gosh. You're a good person.
That's all you need to hear.
Yeah, you're a good person. You did your best.
Pat, thank you very much for being on the show, man. Always welcome back. If you're ever in the hood again or whatever, we can touch base in a few months and see where you're at and shit like that. And honestly, whatever, reach out to me anytime and I'll do shout outs, man. I'll keep on pushing it and seeing it. And I'd love to see more and more kids and even, you old guys.
Oh, man, anybody.
Love to see you guys.
Yeah, for sure.
Maybe I'll try it one day.
I'll
try to figure it out and I'll be DMing you over and over going, I can't fucking figure this out, Pat.
Yeah.
Please send somebody, man. Please. I can't figure. I've already wasted all my lumber. No, this is absolutely. I'm in awe of this stuff. This is absolutely amazing where it came from, where it is, and where the potential is.
Yeah. Well, Manny, thank you very much. I appreciate it, and I sincerely do. And thank you for all the work that you do as well.
Thanks, man. Yeah. Reach out to him, man. Everyone who's listening, reach out. You got questions, and you want to be a part. You want to be a student.
Yep.
By all means, right? You're always open to more students, right?
Always. Yeah.
Okay, I think that's it, man.
Cool.
We're all done. Thanks,
That's awesome.
Angelina. We're out of here.
Thank you.